What's up, math scholars? Mrs. Harp here. We're going to do more graphing today. Get your calculators ready. Hope you're having a happy day. Today is October 26th, Pumpkin Day. We have a lot of kids dressed as Christmas, and 4th of July was popular too. You could have stood up for St. Patrick's Day. Anyways, who's excited to graph some functions? Woo! Yeah! All right, we have a couple reviews of old concepts that you have to have fresh to be successful today. Do you remember what a degree is?
Highest.
Good. So what's the degree of this one?
2.
Awesome. It's the highest exponent you see in the polynomial. What's the degree of this one? 1. Good. It's the highest exponent you see in the polynomial. You might be wondering, how are we going to use that today? We're going to look at the degree on the top of the fraction, we're going to look at the degree on the bottom of the fraction, and we're going to compare the numbers. Okay. We do also need to review the old-fashioned factoring method. So it's been a few months. On the first one, you are looking for numbers that multiply to negative 12. So 1 and negative 12, negative 1 and positive 12, 6 and negative 2, negative 6 and positive 2, etc. And you run down the list in your head or on paper to brainstorm. And then you select the one that also adds up to negative 1. So do you remember doing this? Awesome. What did you select? Perfect. And then I have it behind this box, but it says we're supposed to list out the zeros of the functions. Zeros are the same thing as solutions. So if I had this set equal to 0 and I needed to know the solution of this binomial and the solution of this binomial, what would the solutions be? Good. I think you guys remember that. Awesome. Let's do the same thing here. Let's set it equal to 0 and find the solutions of this binomial. So factoring is an easy way of doing it. What numbers multiply to negative 25 and add to 0? 5 and 5. One's positive, one's negative. And so my solutions, positive 5 and negative 5. You can write it like that. Fine. Can somebody raise their hand and tell me another way I could have solved this equation without factoring? Yep.
No.
Maybe.
So you set up the x plus and minus and then 25.
No, I mean, if I hate factoring and I don't want to use factoring, there's another way to solve this one. Just add a 25 to both sides, right? And take the square root. Now that was not an option up top because we had more variables, but that would have also yielded the same answer. Positive negative 5. I'll use this technique today, so I'm going to recap it. Same method will be used on this one. If I need to solve this for x, I would set it equal to 0. What would I do first? Add 5 to both sides. What would I do second? Square root. So my solutions would be positive or negative, radical 5. This is just recapping some of the skills you'll be using in the lesson. Okay? So any questions on any of those skills? Okay, so I'm going to put this up here, but then pause the video so you have writing time. These are the 3 main steps you can use to graph any rational function. And that's why I actually erased our steps from yesterday. Our steps from yesterday are basically the same thing as this. You're going to find your x-intercepts by setting the top equal to 0 and solve. Our graphs yesterday, we didn't really worry about x-intercepts, so we never really did that. We're going to do it today. To find vertical asymptotes, you set your bottom equal to 0 and solve. And then the horizontal asymptotes are interesting. You will look at the degrees of the top, the degrees of the bottom, and then use a little chart I'm about to pass out to you. Okay, so this is the chart I just passed out to all the kids in the class, and I kind of drew their attention that the bottom part is the part you'll be interested in using, because you will be comparing the degree on the top, m, to the degree on the bottom, n, and then referring to the chart to figure out information about the horizontal asymptote. All right, so let's try our first example. Step 1 was taking the top and set it equaling to 0. That helps you get the x-intercepts. Does that make sense? Could I take a 6, set it equal to 0, and solve it? Not really. So what that means is there are no x-intercepts. Step 2 is taking your bottom and setting it equal to 0. That helps you get your vertical asymptotes. So let's go ahead and set our x squared plus 1 equal to 0. How would you solve that? Some people even solve these in their heads. Ethan? Right, and so if I subtract 1, I'll have x squared equals -1. Is that a number I can square root and get a happy, nice, real answer? I would get an imaginary answer, which means there really are no vertical asymptotes. Okay. This was setting the top equal to 0. This was setting the bottom equal to 0. Now what is step 3 on that you wrote down? Comparing the degrees. So, what is our degree on the top? We call that guy m. It's actually 0 because there's no variable. So it's just a constant, like 6, the degree is 0. So m is 0. Let's look at the degree in the bottom. Would you say the degree in the bottom is? So that's n. And now you look at your chart. So I think what we just concluded is m is 0 and n is 2. So therefore m is less than n. Would you agree? M is less than n? That's the very top entry of the chart. And what does it say in that top entry of the chart? Y equals 0 is the horizontal asymptote. So really, that's the only asymptote to draw in on this example. It would be a horizontal line through 0. Now these graphs are going to look real weird today. They're not going to look like your traditional hyperbolas like from yesterday. So go ahead and type it into your graph world. Make sure you're using parentheses around the bottom to group that x squared plus 1. And we'll do our best job at drawing it. We are back live. All right, let's follow our 3 steps. What is step 1? Set the top equal to 0 and solve. That will give you your x-intercept. So help me solve this. Divide by 2 on both sides, and then square root 0. So we just figured out that x equals 0 is an x-intercept. Now that's an intercept, not an asymptote. So you make a dot at 0, not a line. Make sense? Easy enough. Step 2, set your bottom equal to 0 and solve. That will give you your vertical asymptote. So who's my bottom? X squared minus 9. We're going to set that equal to 0 and solve it. I'm going to erase just to give myself more workspace. So I'll add 9 to both sides, and then I'll square root. What would that give me? Positive 3 and negative 3. So you know what that means. I have 2 asymptotes, 2 vertical asymptotes. 1 through positive 3 and 1 through negative 3. And then my personal favorite, my horizontal asymptote, I come up with by looking at the degrees on the top and the degrees on the bottom. So what's my degree on the top? That's my m value. 2. What's my degree on the bottom? That's my n value. 2. And so let's look at our chart. It says if m equals n, the line am over bn is a horizontal asymptote. Now you're like, what the heck is am over bn? It's just the leading coefficient of the top and the leading coefficient of the bottom. So it's that a over c trick we did yesterday. Remember how we did leading coefficient over leading coefficient? So in this case, it'd be 2 over 1. Okay. That's y equals 2. So this graph has 3 asymptotes. We've never seen a graph with that many asymptotes. So if you have not yet, graph it. Use parentheses around the top and bottom. It's basically like some sort of upside down parabola with 2 branches up here that are kind of hyperbola-like. Isn't that nuts? It's cool. I like it. These graphs give some wild shapes. All right, so the best way to come up with domain and range is just look at the picture. My domain and range, it looks like it could go left and right pretty much everywhere except for where those 2 asymptotes are. So I'll go with all reals except 3 and negative 3. And then for range, there is a weird thing that happens with the range. It can go down really far. It can come up to 0. But then there's this like dead zone from 0 to 2 that it will never, ever, ever touch. So here's how I'm going to say that. It can go from negative infinity up to 0, including 0. So bracket around 0. Then it doesn't pick up until 2, and then it goes from 2 to infinity. Okay. Not including 2. There's an asymptote at 2. Now, if you have two different sets of numbers and you want to kind of include both those in your answer, you put a U between them for union. Did you see a union symbol in geometry last year? Union and intersection? That's a geometry thing. Intersection is an upside down U, and union is a right side up U. I bet you saw it and forgot. Alright, I know there's not a ton of time left, but I at least want to start the next example because I want to show you how sometimes you need to use factoring to solve, okay? So if we don't finish, I will finish the video after you leave. You can watch on YouTube. But I definitely want to start it, okay? You ready? Okay. Okay, last one. In fact, we probably could just do step 1 of the last one, and then you'll be good enough from there. But step 1, which is set your top, equal, and solve, I wanted to show you how sometimes factoring is necessary. So if I go to set my top equal to 0, I've got x squared plus 3x minus 4 equals 0. I have to use factoring to solve it. So can you think of my numbers I need? The numbers that multiply to -4 and add up to +3? +4 and -1. So that gives me my two solutions, which are my two x-intercepts, -4 and +1. If I put a dot, that's location. X-intercepts are dots. Setting the bottom equal to 0 in solving is a piece of cake. You do x minus 2 equals 0, so what would that solution be? And that is an asymptote. So you make your dotted line, too. These are long problems, I know. There's just a lot to them. You set your top equal to 0, solve. Those are your intercepts. Set your bottom equal to 0 and solve. That's your asymptote. And then my favorite one, we get to compare the degrees. What's the degree of the top? That's my m value. What's my degree of the bottom? That's my n value. 1. So I use my chart. I'm concluding that m is larger than n. And that on the chart is the bottom entry. And it states that this graph has no horizontal asymptote. So none. If you want to save time and not type it in, I'll just go ahead and show you what it looks like. It's this really, really, really strange, sideways looking hyperbola that almost looks like a boomerang, I think. And you have to zoom out once to be able to see this branch up here. So now that I drew it for you, let's just answer our domain and range questions. So domain, what do you guys think? It's actually all real numbers except for 2. So all reals except 2. Because it goes over here too. Yeah. If you didn't see the other branch, you can zoom out once to see it. And then range? I would just go with all reals for range. I know it technically cuts off in here, but there's no asymptote that's forcing that cutoff, so for what we're doing in this class, all reals would be fine. Alright, I'll leave it up because I know some people are catching up. I'm going to go ahead and pass the paper out. It's a half a sheet of worksheet, okay? Pause.